Quantum Feedback Loop podcast. I'm your host, James Myers, and I also publish the Quantum Record, which features the latest in science and technology. Today we're talking with Arushi Nath. Arushi is an extraordinary high school student who developed a passion for asteroid research when she attended the 2021 Planetary Defense Conference. In our discussion, you'll hear Arushi describe the time that she spends not only observing asteroids using a number of different sources, but also how she applies her coding skills to pinpoint more asteroids from among other objects in our solar system. By adding to the database of objects that could approach or threaten Earth, Arushi is enhancing the ability of science to defend the planet with early warning of potential dangers. It's so encouraging to hear how Arushi and youth like her around the world are engaging with science in such innovative ways. And I hope this discussion will leave you hopeful for the future, with bright young minds like Arushi's adding in such a great way to crucially important missions like planetary defense. Welcome, Arushi, to the Quantum Feedback Loop podcast. Really excited to have you here today.
Thank you for having me.
You do a lot of work with asteroids. So tell me a little bit about how you became interested in asteroid research and what sort of things you're doing.
Definitely. So it actually started in about 2021, where I attended the Planetary Defense Conference. So this was a conference all about asteroids. And I got to learn that there were over 1 million asteroids that had been discovered so far, and hundreds of new asteroids are discovered a month. And I found that really fascinating. And I even learned that some of these asteroids, because their orbits were uncertain, could come near the Earth. And if they did collide, that would cause catastrophic damage, as we've seen in past collisions. And my favorite part about the conference is that they also had a simulation of an asteroid collision. So every day they would basically release more information on an asteroid that had a possibility of colliding with the Earth. And they would give damage scale, they would give information about where the asteroid would impact. And this really fascinated me and made me think, what can I do in asteroids? Can I develop algorithms that can support the discovery of asteroids? And that's kind of where my first project started along. Um, I tried to use my other skills, my skills in coding, and then mix them with my skills in astronomy to be able to create algorithms which used images of the sky to basically find unknown objects or unknown asteroids by first removing all known objects, so known stars, known asteroids, and then trying to find the unknown asteroids that left off, and then reporting the unknown candidates to the Minor Planet Center database. So that was my first step in actually making a complete asteroid research project.
Wow, that's really interesting. So where do you get the data from when you're getting these data sets saying you're removing the known objects? What data sets are you using? What sources are you using?
So all of that data is actually open data. So it's data that's open source that anyone can use. And for example, when I was trying to find all known stars, I used the European Space Agency's Gaia or data released, early data release 3, because that was what was released at that time. And it basically provided a complete catalog of all known stars up to a very high magnitude. And then for finding known asteroids, because I didn't want to rediscover an asteroid that was already known, so that's a tricky thing because asteroids are always moving. So how do you know their position? So that's when I queried the NASA's Horizons database, which basically gives the ephemerides of the asteroid. So using their orbital computation of the asteroid, they're able to predict where the asteroid will be at any given time. And knowing the time that my image was taken, I was able to find all known asteroids.
Well, that's incredible. And so you said you do coding as well. Where did you learn the coding skills?
Um, that will come from definitely open communities, open workshops. I believe in the power of open tools. For example, to learn Python, which is an open programming language, I used to go to workshops locally in Toronto, but then I found one of the best ways to learn coding, especially as the world turned more virtual, was actually to just look at online courses from places like Coursera, and just lots of self-learning. And once I learned a few basic skills, I tried to apply them into projects because I believe once you do a project, that really forces you to actually explore the programming skill, make sure that you've actually learned it properly, because then you have to apply it in almost like a real life scenario.
Wow, that's it's amazing that you're able to do all of this and you're in school, right? Does any of this tie with your schoolwork?
Well, honestly, I started in grade 7 where school studies were easy, which meant I had a lot of time to basically work on my research and be able to spend a lot of free time trying to basically create my algorithms and then test them out. And I must say my schools have been very accommodative. Like for example, when I had to go give research presentations, I was given time off to be able to go and do it. And in the end, I was able to actually go back to school and then make presentations on basically what I've learned over my asteroid research. I've been able to share some of my research and algorithms. And I think that's the best part after you learn stuff, being able to share it back to people around you.
Yeah, that must be really interesting for the other students. Do you work with any other students on this, or is it just research that you do on your own?
So far, it's been research I've been doing on my own at least. Um, I guess finding people who are interested in astro research definitely around you is sometimes hard. But over the years, I've learned that sometimes people don't need to be exactly around you. Like for all of my research projects, I've been able to reach out to astronomers, scientists from all around the world. For example, when I was creating algorithms basically during NASA's DART mission, I was trying to measure the physical properties of the asteroid Didymos. And there I was able to reach out to members of the DART team. For example, I was able to set up a meeting with their observational group lead, Christina Thomas, where I got a chance to learn about how high the signal to noise ratio of my observations of the asteroids should be to be able to get accurate results and accurate photometry. And it definitely helped me across my journey. But I think definitely one of the most interesting collaborations I've had is just collaborating with networks of citizen scientists from around the world, from places in the United States, Chile, France, Canada. And this was especially the case during the DART mission because right after the mission, everyone was trying to observe the target. It was a target of interest. And by collaborating with all of these people, we were able to get global coverage of the asteroid. Like, for example, if one person's skies were cloudy, we were able to get the observations from another place. So I think definitely these collaborations are very important.
That's really interesting. And so the DART mission was where NASA sent I guess, a probe to kind of push an asteroid or change the orbit of an asteroid, right?
Yeah, so
Yeah.
DART mission, it was a mission in 2022 launched by NASA, and their goal was to test the kinetic impactor technique of impacting an asteroid, so head-on impacting it with a spacecraft. And their target was Didymos Dimorphos, which is the binary asteroid. And what they did is they hit the moonlet, so the Dimorphos, the smaller asteroid, to try and change its orbit around the bigger asteroid, Didymos, to simulate almost like a planetary defense scenario.
And what's the discussion since that event has happened? And you mentioned the collaboration that you're doing with these other people who are following that as well. Has there been any more discussion or talk about improvements or changes to such an approach? I guess, sometimes these asteroids come out of nowhere, and is there enough time to even launch a defense with something like that? Is there good progress being made on that front?
Definitely, yeah. For example, one thing to keep in mind is that NASA's DART mission isn't the only planetary defense mission that's being launched. Definitely, that mission was really important, and it showed an impact technique which is very useful if we have plenty of warning time, like at least 5 to 7 years, so we can slowly change the orbit of the asteroid. But if there was less warning time, for example, then definitely other techniques need to be involved, and that's why several countries around the globe are launching their own planetary defense missions. For example, European Space Agency is launching Hera, which will go back to the Didymos asteroid and be able to study it in more detail. Also, other countries, for example, Japan is launching their Hayabusa 2 Sharp mission, again targeted at asteroids. Also, NASA is also launching the Osiris Apex mission for Apophis, and China also has its own planetary defense missions. The interesting thing about these missions is that they're also targeted at smaller asteroids, which are like 30-meter asteroids, and these are actually the asteroids which are more likely to be undetected. And they're also the largest population of asteroids, the smaller ones, which means they have the highest impact probability. So it's very important to learn about them.
Yeah, that's really encouraging to hear, I guess, that there's all of these missions going on, and I guess learning a lot in this process, which will hopefully improve the response time or decrease the response time to these events. What role are citizen scientists like you playing in these events? So, do you have ongoing contact with the DART team, or have you connected with the other, you mentioned the ESA in Japan and China? Are you and other citizen scientists involved in the work that they're doing?
Definitely in every planetary defense mission, every mission in space, honestly, citizen science contributions are very important. For example, the number of professional telescopes in the world are very small. There's only about a dozen or less, which means that to get observations of, for example, during DART mission, to get observations of Didymos, the NASA DART team did reach out to citizen scientists and did use citizen scientist
Hmm.
observations to be able to improve their light curves, improve their observations when they were doing pre-impact and post-impact analysis. So I think citizen scientist contributions are very important no matter the mission, even the future missions from the space agencies around the world. Um, Targeting these asteroids through citizen scientist telescopes will be really important. Perhaps the ones that are 30 meters or smaller might be too faint, but even the slightly bigger ones, as long as the good thing is that citizen scientists have time, and likelihood is that the orbit of these asteroids will bring them close to the Earth at some point, where it'll be observable from small aperture telescopes, which are plenty around the world. So that's when we'll really rely on citizen scientist data.
How much time do you spend doing this research?
That's a great question. And honestly, I found that when you're passionate about an issue, sometimes it's really hard to keep track of time, and it can take, sometimes you can be stuck in a problem and then take hours on end for weeks trying to solve the problem. While on the other hand, sometimes you take long breaks to try and get new ideas, to try to refresh your memory and then think of something new. So for me, I found I spent as little as maybe 1 or 2 hours in a day to continuously working over it for weeks and weeks on end. One of the examples of the weeks and weeks on end is during the time of the DART impact. And right after it, I was really excited. I was trying to get my results as soon as possible. And at the same time, like I was trying to get as many observations of the asteroid as I could in. And at the same time, I was also trying to improve my algorithm and finish it off so I could actually input all of the images and data I had collected into my algorithm to be able to determine the physical properties. So that's a time when I was just working and trying to get it done as soon as possible.
So how has your research evolved since you started? I guess you mentioned in 2021 you went to the Planetary Defense Conference. You were interested in the simulations at that point, then you developed coding to remove the known objects and look for asteroids. So how has that sort of evolved since, I guess, if it started in 2021 to now?
Well, I think my research has evolved in, I had three main phases. So first, as you mentioned, that was near the Planetary Defense Conference in 2021, when I was really interested in trying to find unknown asteroid candidates. So that was the first phase, just scanning a large amount of sky data to be able to try to find unknown objects. And that was the first phase. The second phase is near when DART mission came up, where I wanted to expand my research and see if citizen scientists could actually provide support to a real life planetary defense mission. So this was when I was focused on a specific target, the Didymos binary asteroid, and my whole research was centered around it for around a year. And my latest phase was where I wanted to expand all the research I'd done in the DART mission to be able to characterize large asteroid populations. And this is especially important because, as I said, several countries are putting up planetary defense missions, and these missions are basically aiming at asteroids and aiming at 30-meter asteroids, aiming at smaller asteroids. So that's really when I wanted to be able to analyze these asteroids first to try and see if I can provide support to these missions too. Um, so that's when I created my algorithm. I called it FAST, as in like PHAST, to be able to I characterized about 2,100 asteroids in the first 100 hours of running my algorithm. So that was my latest video.
Wow. And so as you're characterizing these asteroids, then where does the data go and who does the next step with that data?
Yeah, so asteroid characterization keeps on improving. There are several databases that keep track of basically the physical properties of asteroids. For example, NASA's has their own Jet Propulsion Laboratory database. And basically, I was able to characterize these 2,100 asteroids, generate their phase curves, and basically find their physical properties, and then cross-match them with the NASA's JPL database. And then this gave me the confidence that I would need to basically apply this to hundreds of thousands of asteroids, some of them that may not even have been characterized in detail yet because they've just been discovered.
Okay, so you're feeding your information back into these databases to help to build them out, I guess.
Exactly, that would be my goal.
Yeah, yeah, wow, that's incredible. So you mentioned a million asteroids. That would be in the solar system.
Yes, that's true.
And so you mentioned the simulations as well. Are they still doing simulations?
Yeah, Planetary Defense Conference is held every 2 years actually. So the last one was in 2023, where I got to participate in person, and they held their same simulations there. And I think these simulations are a really great experience, especially since the data isn't all released at once. It's released in steps, which allows you to basically see how different bodies interact with each other as this information comes out, whether it's political bodies, research bodies, and how decisions are made. And the next Planetary Defense Conference is actually in 2025, and I hope to be there in South Africa.
Yeah, that'd be really interesting. And so the simulations that you're looking at, if they were more widely distributed, I guess, would that get people really interested in this important topic? It's a topic that, planetary defense, crucially important, of course, but it doesn't get a lot of press coverage, right? So how do we get more people interested in this?
Definitely, and I think asteroid simulations are really important also because they give more of an interactive and hands-on experience because you get to actually make your own decisions. And there's an organization, American Institute of Aeronautics and Astronautics, AIAA, where basically they run similar types of simulations. Also, I got to participate and help present in some of their workshops. And that's where basically they give you, for example, a specific target. Of course, it's a hypothetical target, and then you get to decide how you would want to launch your deflection mission. How heavy would the spacecraft be? So this would be like in a kinetic impactor method of impacting it. And I think those type of events really brought together many youths, brought together many kids of younger age who wanted to try it out. So I think having lots of these outreach opportunities is really important because it gets the next generation involved.
That's great. And actually I would be really interested if you were able to send me some of the links for these things online because I'd like to share them with our listeners. I think
Definitely, I'd be happy to share them. Yeah.
yeah, that'd be great. So you mentioned other youth in, locally here in Toronto where you live. Are there youth that you're interacting with on a regular basis on asteroids or around the world? How do you make connections with other young people?
I think the amazing thing is that young people are everywhere and they're trying to make a difference right now. And having participated in conferences nationally, internationally, and I'm optimistic that the next generation are trying to use technology and innovation to solve these ongoing and emerging challenges. And through, for example, science fairs, conferences, I've been able to meet youth not just in Toronto or Canada, but also internationally, which is honestly one of my favorite parts, these international collaborations, international talking, even when your subject of expertise isn't necessarily the same. One might be interested in medical research, another in like planetary defense. But I think having like-minded, having similar skills, or even having completely different skills can actually help you and maybe foster even future collaborations.
Hmm. And do young people from different parts of the world bring different perspectives onto these questions? I'm just thinking, when I was young, of course, there was no internet, there was no easy way for people to connect, there was no online information databases and all of these things. So it's really an amazing world now where you can connect with anybody across the planet. And so I'm just wondering, are the young people in, say, South Africa, which you mentioned the next planetary conference is, do they approach things with a different perspective? Do you find that, or do you find that there's kind of a common approach, common interest developing online?
Yeah, well, actually, last year I got the chance to represent Canada at the European Union Contest for Young Scientists, which brought together youth from Europe, but also youth from all around the world. And that was a great experience to be able to see how different people tackle different challenges, for example. And I found that one of the main differences is that different locations have different challenges. Some might live in places where droughts are more common, some maybe wildfires. So I think it was really interesting seeing that many people came from places where different issues were more prominent, and to see youth be able to try to use the skills they know to tackle these challenges. I think was really interesting. So some challenges that people really knew because it happened a lot in their location might not be true for others. Um, and I think seeing those different perspectives was definitely very interesting.
Yeah, I'm interested in hearing more about these conferences that you've gone to. So you've mentioned the Planetary Defense Conference, European Contest for Young Scientists. I think you also went to the Canada-wide Science Fair. So what happens at these conferences? How does it work? And you're presenting at some of these as well?
Yeah, I can take you through the few that you mentioned.
Yeah.
For example, the Canada Wide Science Fair. So that's basically a prestigious national science fair where the winners of over or about 100 regional science fairs across the country come to compete. So, for example, Toronto, when I went, had 10 representatives, and this is a competition. So kids can basically make their own posters and then present them to a series of judges, and then they're judged based on that. So I was lucky to be able to win the top award in my first year of participation in 2022. And as a top winner, you are normally invited to present or compete internationally at the European Union Contest for Young Scientists as a prize. Unfortunately, the first year I was actually too young, but that made me more and more determined to try and my best next year because I was actually 13, but the minimum age was 14. And the next year, I was actually able to win the top award and actually represent Canada at the European Union Contest for Young Scientists. And that's where basically winners of national fairs from people all around the world are selected to come and compete here. So about 34 countries participated in USIS. And this was like only 2 to 3 people came per country. So it was really a chance to actually get diverse voices of people around the world. And so this is a 1 week event where you get to present your project to judges for a few days and also get the chance to interact with other youth. And I think I was lucky enough to win the second grand award, which showed that my work over the last year really paid off. And I think if there's any young people out there wanting to get into any science research, whatever the discipline, I think science fairs is a really good method because after you spend a long time working on a project, it's very rewarding to be able to actually talk about it with subject expert judges and be able to see what other kids have also accomplished. So I think these science fairs are really a very important experience to have. And the last one, the Planetary Defense Conference. So this is more of a research conference. So I submitted an abstract on my project and was very happy to see that it was accepted for poster presentation. So I actually got a chance to go in person. So the 2023 Planetary Defense Conference was held in Vienna. And I think it was a really good experience because this conference was all about asteroids, and that's what I'd been working on for the past 2 years. I got to interact with people who I'd been in contact with only virtually in the last year. And I got to also meet the whole NASA's DART team as they gave presentations about how successful the DART mission was. I think it really gives you an opportunity to learn about future missions and see what other research is being done in asteroids. So I think that finding your type of planetary defense conference, for example, if you're interested in asteroids, PDC is really for you. If you're interested in medical or other subjects, then there's other conferences. Um, but I think all of these conferences really give you a way to express your research and then show what results you've got.
Congratulations on your success in those. It sounds really interesting. I guess so at the science fairs, were you the only person doing asteroids or was there other presenters involved in asteroids as well? Or what was kind of the range of the projects that won the prizes?
Yeah, definitely. There was a huge range, and there were definitely many asteroid projects, many space projects. There was actually so many that now the Canada Wide Science Fair, because they're separated into categories, now they have a whole category just for aerospace and astronomy, which is amazing. And I think prize winners ranged from every topic, all the way from medicine to robotics to space to physics. And I think many youth are interested in many different subjects, which is great. And I think some of my favorite parts was seeing projects which mixed multiple disciplines together, um, like mixing robotics with, for example, medicine, and seeing how those mixes happened are really interesting. But I think all types of projects were there for sure and represented in big numbers.
What would you say is the most interesting thing you've discovered so far in your research?
Um, that's That's a great question. And I think one of it is in my latest research, which was focused a bit more on large scale asteroid populations, so being able to determine the physical properties of thousands of asteroids. And one of the most interesting things I learned is because asteroids are not internally differentiated, which means what you see on the outside is normally what's on the inside, and the surface composition is the same as the inner composition because these objects are so small. So using the surface of the asteroid, which I was able to look at through pictures, I was able to determine asteroids if they were metallic, silicaneous, or carbonaceous. And I was able to apply my algorithm to 2100 asteroids. I discovered 58% of asteroids in our solar system are carbonaceous, ranging from 75% in the outer main belt to 58% in the inner main belt. And this allowed me to determine a bit about the early solar system conditions because it indicated that these carbonaceous asteroids likely originated in the cooler, volatile rich regions of the outer main belt.
Hmm.
And for me, this was amazing because it showed that my algorithm could actually delve deeper into the formation of the solar system. And this is even something that can be expanded to other solar systems in different ways.
Wow, that's fascinating, actually. And so I hadn't heard the term carbonaceous asteroid before. So tell me a little bit more about that. What differentiates the composition of that to a metallic asteroid, for example?
So carbonaceous asteroids are one of the most popular asteroids, and it basically shows what they're made of. It means they're volatile rich, they have carbon inside them, and they have a large amount of carbon, whereas, for example, silicaneous asteroid would be mostly rocks and minerals, whereas metallic asteroid would be mostly metal. So this basically shows what materials made the asteroid. So these are the three most popular types: carbonaceous, silicaneous, and metallic.
Hmm, okay. And you said carbonaceous, I think you said 58% was the number that you gave?
Yes.
Yeah,
That's the
interesting.
number that my algorithm was able to find from the 2100 asteroids it analyzed.
Okay. And you said that because they're carbonaceous, they originated in the cooler areas, I think you mentioned.
Yeah, because I found that most asteroids were in the outer main belt region, so
Hmm.
75% compared to only 58% in the inner region.
Hmm.
So, which showed that these types of asteroids likely originated in the cooler regions, where there was lots of volatiles, and this is in the outer main belt.
Do the different types of asteroids represent a different type of threat to Earth? So is a carbonaceous asteroid less or more threatening than a metallic or silicaceous asteroid? Or is there no difference?
Definitely, there's a difference. Easily enough, like for example, lots of these objects have different weights, different densities. So that'll, for example, if you were trying to deflect an asteroid, you would need to know these properties to be able to see how much you have to impact, how much strength you have to impact the asteroid with to be able to deflect it. Also,
Hmm.
some of these materials burn up more easily in the atmosphere, like carbonaceous might burn up more easily, while metallic and silicaneous asteroids might not. So I think composition is definitely a very, very important part to know about an asteroid to see how it would react when it impacts the Earth.
Yeah, I didn't realize that. Yeah, all those differences. I guess you don't only have to identify the asteroids; you have to identify what type it is, and then how it's going to behave. I guess in the atmosphere.
Exactly. Like there's
Yeah.
several important characteristics that you need to know, ranging from like their size to their composition, also to like their strength. Is it one big asteroid or is it many, many small little rocks held together by mutual gravitation, which is called a rubble-based asteroid? So these are completely differentiate what type of impacts these asteroids would have.
Hmm. So there was the asteroid. I think it was what was it, 2013, that struck near Chelyabinsk in
Yes,
Russia.
that's true.
What type of asteroid was that?
So that was a 10-meter asteroid. I'm not too sure about the composition, but it was 10 meters, which is on the size range likely enough to cause slight citywide damage, and that's what it did. It injured thousands of people in the Chelyabinsk city, and it caused damages to the ice, to the buildings.
And there was actually, I can't remember, it was maybe last year, late last year at some point, there was a small rock that actually struck, I think, an hour outside of Toronto. It didn't strike a populated area, but these things just come out of nowhere, I guess. And so mounting a planetary defense mission, as you said, could take years. How are we going to deal with these kind of appearances that they just come out of nowhere? Is there any interesting ideas about how to deal with that when you really don't have that much time to prepare?
Definitely. Well, first of all, ideally, you would of course have lots of time to prepare so you can get the best method possible and the least risky method. And one way to do that is to basically try to detect and analyze all of the asteroids in the solar system as fast as we can. And that is what we're trying to do by detecting hundreds of near asteroids every month. But I think if we do have a very short working time, then our options are very limited. The main option would be to use like nuclear weapons, which is not preferable. There's several space treaties and laws which talk against the use of nuclear weapons. There's actually no treaty that says where using nuclear weapons is acceptable. So that means, for example, if you try to launch a nuclear weapon, you miss, and then it impacts somewhere else, then you could have lots of liability issues. So it's really a last resort item, but it's one that would technically need to be done if there was a big enough asteroid with a big enough impact risk on collision to the Earth, and we had nothing else we could do.
Yeah, for sure. And so, as you say, I guess the really best defense at this point now is to identify as many of these objects as possible and to make sure that their trajectories are being tracked, right?
Exactly, that's true. So we can predict them well in advance, which is why all of these detection and loss capabilities are becoming so important nowadays.
So the next planetary defense conference you mentioned was in 2025 in South Africa. What's on the agenda for that? And I'm wondering beyond that, what do you think is the most interesting area that they'll discuss there, but also going beyond there, what the most interesting, promising area that you foresee?
Well, while the agenda hasn't been released yet, there's definitely several interesting ideas that I think will come in this session. First of all, definitely for more space agencies who are launching planetary defense missions, there'll definitely be a lot of talks on how these missions are progressing. In addition, the upcoming Apophis close approach is slowly coming. So in about 5 years now, in 2029. So definitely revolving around this close approach and what interesting science. I think that will be definitely a main topic. And as usual, there will definitely be the actual simulation, which I will look forward to. And one thing I remember from the last Patriot Defense Conference is that there were several interesting sessions where people from positions of political power, like people from the White House, people from different big bodies came and actually had a panel discussion as if the simulated asteroid was actually going to collide with the Earth and what steps they would take. And I think those panels were a very interesting opportunity because it made you see, like from a front seat or front row, how these decisions are happening. So I hope and I think that these sessions will come back in next year, which I'm really looking forward to.
That's fascinating. I didn't know that they were doing that. It actually to simulate the discussion that would happen if there was a pending danger. That's really interesting to know. Is there any public online video of that discussion or?
Yeah, the Planetary Defense Conference videos are all out
Oh,
released on their website, and you can actually go back and see what happened. And
yeah.
my favorite part about these is that they seem very realistic, which actually brings you into what if that scenario actually happened.
Yeah, that's important. That's really encouraging to know that that is being done. I'll take a look at that actually. What was your takeaway from that in terms of how the discussion went? Were they focusing on the right things or were they missing things? I mean, these are people who aren't necessarily experts on asteroids themselves, right? But they're having to make decisions.
Definitely. I think the best part about these panels is that you brought people in from varying organizations, from people of political power, but also people of like different planetary defense bodies, from space agencies like NASA. So I think by bringing in people with different expertise, some more on the decision side, some more on the research side, I think it was very well done because you were able to actually get the tech skills almost or like the ideas from the people who were actually looking at the asteroid in real time. And then the people from the political side were able to first tell it to the public, see how the best way to and what to tell to the public, and also see what should be done and what other groups should they communicate to. Actually, there was even a few lawyers there who were talking about basically any liability issues that would come up. For example, if a nuclear weapon would have to be launched, what would be the effects of that?
Yeah, it's a discussion nobody wants to have, I guess, but it's an
True.
important discussion to
Definitely, yeah.
to be doing. So, for a young person to look around the world today and, there's so much discord and division among people and so many differences and animosities. Is there an opportunity for something like planetary defense to kind of bring people together?
Definitely. I think sometimes it is the issues that bring people together. For example, we saw with the COVID-19 pandemic just a few years ago it was announced, and then it really brought people together trying to find a vaccine, trying to enforce lockdowns. And I think it's really when these big issues come up that it forces different countries and people from all around the world to actually collaborate to try and find solutions. So I think definitely planetary defense can also react in the same way. Um, Hypothetically, if an asteroid were on collision course, different countries would be involved in trying to make sure that didn't happen, whether it's for trying to deflect the asteroid, trying to evacuate locations. Definitely, these are issues that bring people from all around the world together.
Hmm. And COVID, yeah, it was an interesting thing, of course. And it was amazing how quickly they were able to develop the vaccine, but also amazing how so many people disavowed the science and, pretended that the vaccines were dangerous, more dangerous than the virus, for example. And it makes me think of that film, I guess, what was it, Don't Look Up, where I guess, if there were an asteroid discovered that were a danger to the planet, would people just simply ignore it or pretend that it doesn't exist?
Yeah, that's a really good point. I think definitely some people will be like that, but asteroid collisions have happened in the past. We've seen the Chelyabinsk impact. We've even seen the one that whizzed past the CN Tower a few years ago, and it shows that these asteroid impacts are and collisions are real and they could happen at any time. So I think that's something that we have, and that's something that people can actually see and believe with their own eyes, which I think will make it definitely most people will be able to see the actual science behind it. Definitely, there will always be a few people who don't believe in it, but I think as long as we have most of the population actually knowing that this asteroid impact will happen, then that's enough.
Hmm. Yeah, and again, I guess important to get those simulations out there so that people can actually see with their own eyes what it
That
would
is
be
true.
like. Yeah, yeah. So tell me a little bit about Apophis, and are you following that, or do you have any involvement with that? And so Apophis is an asteroid which is being tracked, and you mentioned it's going to approach Earth in 2029. What's known about it now in terms of its potential danger?
Yeah, so luckily Apophis doesn't have any danger, at least risk to the Earth. It used to be on the list of potentially hazardous asteroids, which are the asteroids that could have an impact risk, but it was removed from the list later on. It actually had another close approach to some years ago in about 2019. And it didn't come as close as it will in 2029, but it still came really close. And at that time, it was really bright. So I actually used some of the remote telescopes that I had access to, for example, the Berg-Gaffney telescope, the Phelps telescope, and I was able to image this asteroid. And that was also nearing the first planetary defense conference when I was getting into asteroids. So definitely that was a really interesting opportunity for me. And now that the a much bigger close approach is coming back, I'm waiting for the magnitude to be observable, and then I would definitely like to start taking my own observations and contribute in any way I can.
How big is Apophis compared to, say, the Chelyabinsk asteroid? The Chelyabinsk, I think you said, was 10 meters.
Yeah, Charlemagne's was 10 meters. So Apophis is about 400 meters, I believe, across. So definitely much bigger. And this is a reasonable size. If it were to impact the Earth, which luckily it does not, but if it were, then that would definitely cause citywide and even possibly a bit of national damage. Much bigger than the Chelyabinsk asteroid.
Yeah, yeah, definitely. And it's amazing the kinetic power that these have. Even a small rock, just is going so fast that it unleashes immense power when it enters the atmosphere.
That is true, yeah.
Yeah. So you mentioned some groups like the Planetary Defense Conference. How many groups are there planet-wide working on planetary defense?
Definitely there's many groups. There's several research groups that work on different aspects. For example, there's a group that works more on being able to detect these asteroids, more on being able to look at their trajectory, be able to, if there were a collision course, for example, be able to see where exactly they would impact. While there's other groups who are more focused on maybe seeing the impact region, how how many people will be affected, how can we evacuate this place, and other groups more into how do we tell the public and how do we actually manage this information. So there are several
Mm.
bodies that come together when it comes to planetary defense to be able to work together to prevent asteroid collisions.
And that's encouraging to hear that they're working together and addressing different aspects of the problem, I guess. It's not just all about identifying asteroids. It's not all about defending. It's also about communicating, as you said.
Exactly.
Yeah.
Communication is really important.
Yeah. So, in terms of other youth, are you collaborating with any other youth now on any particular asteroid project?
Not currently, no. But I definitely hope to do that in the future. Just became a Mason Fellow, which is a fellowship funded by Japan and gives the networks and resources that allow you to pursue your research further. So I'm hoping from these networks that I've just gained, I'll be able to create new collaborations soon.
That's great. And so you are doing more coding. I guess are you learning more coding or expanding your coding skills at the same time?
Absolutely. And I think all of these projects give me a great opportunity to not only work on the project, but also expand the skills that I'm using to make these projects. So, for example, going more into artificial intelligence, machine learning, and being able to apply that into planetary defense, I think is really important. And also, mathematical skills are also really important, as well as just creativity and knowing, seeing how to express your results, for example. So, I think all of these skills really build up as you're working on projects, and projects almost give you an excuse to actually work on them.
It's great. And your teachers and your parents must be incredibly proud of the work that you're doing and supporting it.
Definitely, it supported me along the way. For example, school giving me breaks and holidays when I needed to go to conferences, and then parents supporting me all throughout. So
Yeah,
definitely, they have been a big support.
that's great to hear. What do you hope for the future of the world, of humanity, of today's youth? When you look ahead and, there's so many problems in the world today, I mean, how do you see things going? What's your biggest hope for the future?
Well, I'm seeing that the world is heading in almost like two directions right now. Because in one end, we're seeing the reemergence of older issues, for example, pandemics, like COVID, and also older diseases coming back. And on the other end, we're seeing issues that we never would have thought would arise, and they're coming because of newer technology, for example, algorithmic bias. And the commonality between both of these types of challenges is both require open data, both require more youth invested. They require foresight, they require long-term investment, they require collaboration. But the problem is we are right now working within almost like a shrinking environmental space where there's shrinking public funds and the world is becoming more polarized. And where the political willingness to invest in long-term solutions which are desperately needed is depleting. So I think why I hope is that the interest of the future generations are preserved in all ongoing decisions and actions that are being taken.
Yeah, and as you say, the long term often gets overlooked. And so, in terms of what asteroid research can do for the other problems in the world, is there any other consequences of asteroid research in other areas that can help the world?
Well, definitely, once you know how to basically whatever skills and even sometimes the techniques that you do for astro research can help with Earth-based challenges. For example, my first project was like finding unknown asteroids by basically using an image and then pinpointing all known objects, counting them, removing them, and that similar type of techniques can be applied by taking satellite images of, for example, a park and being able to count how many trees, find the tree density. So I think all of these techniques and skills that you use for planetary defense can always be applied towards the Earth to also benefit other challenges.
And are you confident that we are discovering enough asteroids or that we're on track for discovering enough asteroids that we can defend the planet?
Definitely, like we're continuing to detect hundreds of asteroids as our detection capability improves. It could even be even more, and we're especially now detecting the smaller asteroids, which have stayed undetected because of their size. but now as we have better techniques, we're able to detect them. And these asteroids, as I mentioned earlier, is really important because they're the ones with the biggest population, which are most likely to impact the Earth. So I think the detection is good. It's actually the analysis that we're struggling right now because we're not able to keep up with the analysis of these hundreds of asteroids we're detecting. So definitely that was one of my goals in creating like basically large asteroid scale analysis to characterize asteroids to try to speed up the rate of analysis of these asteroids. So I think detection is really important, but so is analysis, so that we are prepared on and know all of the physical properties of the asteroid if it were to be on collision course.
Yeah, I guess that importance of and the benefit of computerization and artificial intelligence and machine learning can really help with that analysis.
Absolutely.
Yeah. How many asteroids are there that are currently classified as potential threats, right? I guess what levels of threats are there? Like, is there different levels that they're tracking?
Yeah, so there's several different levels. For example, there's asteroids, and there's also near-Earth asteroids. So these are asteroids whose orbit brings them close to the orbit of the Earth. So this can raise the possibilities of collisions. So there's about 30,000 of these asteroids which are discovered so far. And it doesn't go just there. There's also potentially hazardous asteroids. So these are asteroids where their orbit is even closer. They actually come within 20 lunar distances to the Earth. And this means that there's a much higher probability of impact, and we have to basically monitor these asteroids very carefully. So these are called potentially hazardous asteroids or PHAs, and there are about 2,000 of these which are discovered so far.
Interesting. And if they were to come close to Earth, I have heard, I guess there's what they call the keyhole where the asteroid, if it's going to enter the atmosphere, has to approach it in just the right way. Like it can't just enter from any angle, right? Is there a particular
Yeah, well, definitely it'll be dependent on the asteroid's trajectory, based on from which direction it's coming from. Then we'd be able to see what angle it would come through.
well, it's so great to hear about the work that you're doing and great that you're speaking to people about it because it's important to spread the message. I guess to wind up the discussion, how do you think would be the best way to spread the message and get more people involved in planetary defense?
I think outreach is the best one, like basically teaching other youth and spreading the message. That's why I've basically documented all of my projects on made my code open source during all of my algorithms to allow youth and citizen scientists to become plateau defenders, to become active and to basically pursue the issues they're interested in. And I've participated in several events, conferences, maker festivals, and I think giving demos is also really important because it allows you to see actually with their own eyes and then in a more interactive environment. And I've co-created a hot pop robot where I basically undertake 4 to 6 youth targeted events every year for free to make more people excited about using science and technology for public good. So I think outreach is really important.
And what sort of things do you do on Hot Pop Robot?
Hot Pop Robot, I basically document all of my research and make everything open source. And at the same time, I share which conferences I'm participating in targeted at youth so that other youth can also join. And then I talk about projects and try to give kids ideas on what they can do by basically showing them live demos and showing them projects I've made in the past
Oh,
to
that's great.
try and inspire them.
Well, that's great. So that's hotpoprobot.com.
Exactly.
Yeah, that's great. Well, we'll take a look at that as well. So listen, Arushi, it's been great talking to you and so wonderful that you are as committed and involved as you are in this critically important project. And I really hope your enthusiasm for the science and your perseverance with it will become a little bit infectious and grab some other people's interest too, because we really do need to come together as a world and really work on the huge problems which are beyond any one of us to solve. And it's going to take everybody to participate in it, I think.
Absolutely. I definitely agree. And thank you so much for having me in this discussion.
That's great. Well, we will be very interested in following on your work and hearing what happens at the next Planetary Defense Conference. So we look forward to your keeping us up to date and hopefully we'll have another chat soon.
Absolutely. Thank you so much.
Okay, thank you. Our thanks go to today's guest and to you for listening to the Quantum Feedback Loop. Please subscribe to this podcast wherever you get your podcasts. And don't forget to check out the Quantum Record at thequantumrecord.com. The Quantum Record is a monthly journal of philosophy, science, technology, and time, where you'll find the latest developments in our rapidly evolving technological world.